Okay, so welcome to this video. Today we're looking at differentiation and integration. Okay, so with me I have a tutorial sheet full of questions on those topics, and we're going to cover different concepts under integration and differentiation. Okay, so under differentiation, we're going to cover like the power rule, how to find the stationary point, how to find the maximum and the minimum points. We're going to see how we can find the tangent lines, the normals, okay, how we can optimize problems to minimize the surface area, or to maximize functions and the like. And then under integration, okay, we're going to see how we can find indefinite integrals, definite integrals, finding constants, finding the area under the curve. Okay, and then we're also going to see how we can apply the integration, like finding the area between the curve and the line, finding the area between regions that are bounded by the curves and the like. And then at the end, we're going to look at a very special rule, okay, that is very important in pharmacokinetics, which is the trapezium rule. So how do we find the area under a certain curve using the trapezium rule? We're going to see how we can do that. So as you can see, this tutorial sheet here has a lot of different questions, okay, and we're just going to be solving all these questions here. Okay, take note of question 3. It's a very common exam question. Okay, so make sure you know how to solve it. Yeah, so these are the ones we are saying you're finding the area of a region. So we're going to solve all these questions here. And at the end, we're going to know everything about integration and differentiation that is required for us to pass the exam. Okay, so here that's where we're going to be using the trapezium rule there. All right, so let's start solving from the question 1 there. All right, so question 1, they're saying the curve C has the equation, okay, y 4x, the root of x plus 48 divided by the root of x minus root of 8, where x is greater than 0. Okay, so the first question is find the dy dx. Okay, so dy dx is simply the derivative. So they want us to find the derivative of this guy here. Okay, so we're going to find that derivative by using the power rule to differentiate this expression. So the power rule states that if I have a x to the power n, and then I want to differentiate this expression here. It's the same as I bring this n down, so I'm going to have n ax, and then to the power, I subtract a 1. Okay, so in most cases, okay, for most of the questions that are in this tutorial sheet, we'll be required to use the power rule. Okay, so let's try to solve this one. So before we can find the dy dx of this equation here, we need to express it, okay, in a form which is simpler to differentiate. Okay, so what do I mean? We have to express this root of x as x raised to the power something. Okay, so according to the surds and exponentials that we did earlier, we said, okay, the root of x is the same as x to the power half. Okay, so when you see the root of something, just know that it's the same as power half. Okay, so the square root of x is the same as x raised to power half. Okay, and then we also have to know that x to the power minus 1, okay? Or let me just put x to the power minus n, well, where this n can be any number, is the same as 1 over x to the power n. So we're going to be using a lot, okay? We're going to be using these concepts a lot as we will be solving this question. So let us express this one now. So I'm going to write y is equals to 4x, okay? And then this x here, which is the root of x, I'm going to write it as x to the power what? Half. Then I'll say plus 48. So this 48 is being divided by the root of x. Okay, so that's the same as 48. If I have 48 divided by root of x like this, okay, this here is the same as 48 multiplied by 1 over the root of what? X. But we know that this will be 48 multiplied by 1. This root of x, okay, this root of x, we said it's x power half. And if a certain expression is raised to a power and it's in the denominator like this, we said we can write it as a negative power. So this will be 48 multiplied by this guy here. I'm going to write it as x to the power minus half. Okay, so that's what I'm going to put here. I'm going to put x to the power minus half. Okay, and then minus the root of 8. Okay, so now we've expressed it in a form, okay, that will be very easy for us to differentiate. So here I have x to the power 1 and x to the power half. So the bases are the same. So I can write it as 4x and then I add 1 and half. So when I add 1 and half, I'm just going to end up with 3 over 2. So you just do 1 over 1 plus 1 over 2. Okay, when you add this, you end up with 3 over 2. Okay, so that's the power there, plus 48x to the power minus half, and then minus root of 8 there. So we write root of 8 there. So now we can differentiate this. So I'm going to say dy dx is equals to, so the power drops. So it will be 3 over 2 multiplied by 4x, and then 3 over 2 minus 1, okay, plus the minus power will drop, so minus 1 over 2, and then I have 48x minus 1 over 2 minus 1, okay? And then when you have a constant there, the derivative is always 0. Okay, so this root minus root of 8 becomes 0. So we can just ignore it, okay? So when you differentiate a constant, you always get a 0. So what we are going to have from here, okay, will just be simply, this will be 3 multiplied by 4, which is 12, divided by this, that would be 6, and then x, okay? So 3 over 2 minus 1, I'm just going to get half, okay? And then here I'll write minus this negative here, okay? And then it will be half multiplied by 48, which will just be 24. And then let's deal with the powers. So we have minus half minus 1. So when I combine that, I'm going to get minus 3 over 2. Okay, so this expression here will be my what? My dy dx. Okay, so we can keep it. We can write it somewhere here because we use it. So I'm going to say my dy dx is actually equals to 6x to the power half minus 24 minus, oh, I forgot an x here. So this is x to the power minus 3 over 2. So x to the power minus 3 over 2. So this is my dy dx, okay? Then they're also saying find the second derivative there, which is d2 dy dx2. Okay, so how do you find this? You just differentiate what you got here. So I'm going to say d2y dx2 will be equals to, so we differentiate this. So the half drops, so it will be half, and then 6x, and then half minus 1, okay? And then this minus 3 over 2 will also drop, so I have a minus, and then the minus 3 over 2 will drop, then I have 24x minus 3 over 2 minus 1. Okay, so what I get here is 3x, okay? What is minus, what is half minus minus 1? It will be minus half, okay? And then this and this will become a positive, okay? So this will be 3 over 2 multiplied by 24. So that's the same as 3 multiplied by 24, and then you divide by 2. Or you can say 24 divided by 2, which is 12, and then multiplied by 3, which will just give you 36, and then x. So here now I have minus 3 over 2 minus 1. So common denominator, I can say it's 2. 2 into 2 is just 1. So 1, okay, 1 multiplied by this to be minus 3, and then 1 into this, it will be 2. 2 multiplied by that to be minus 2. So it means the power here would be minus 5 over what? Over 2. So that's what I'm going to put here, minus 5 over 2. So it means this one here is my second derivative, or my d2y dx2. Okay, so we'll also keep it because we'll use it somewhere. So let's write it somewhere. So we're going to say d2y dx2 is equals to 3x to the power minus half, okay, plus 36x to the power minus 5 over what? 2. Okay, so we are done with part 1, and then we go to part 2. We are saying use part 1 to find the exact coordinates of the stationary points of C. Okay, so we know that at the stationary points of this curve C, okay, the dy dx has to be 0. Okay, so at the stationary points here, the dy dx will be equals to 0. So we're just going to equate our dy dx to 0 and then solve for the value of x. Once we find the value of x, we're going to substitute it into the original equation to find the value of y. And then we are going to come up with a what? A point. So we are going to say at the stationary point, we're just going to equate x to the power 6x to the power half minus 24, x to the power minus 3 over 2. We're going to equate it to what? To 0. And then we try to solve for x. Okay, so first of all, we can divide throughout by 6, even here by 6, even there by 6. What we get is x to the power half, okay, minus 24 divided by 6, that will be 4. And then I have x to the power minus 3 over 2 is equals to 0 divided by 6, just 0. Okay, so from there now, what can we do in order to simplify this guy here? Okay, we can say, let's take, first of all, this one to the right-hand side. So I'm going to remain with x to the power half is equals to 4x to the power minus 3 over 2. Okay, so once I do this, okay, once I do this, I can multiply both sides by 2. Okay, I can multiply both sides by 2. Or maybe we consider this negative here, because this one has a negative. We can try to multiply with the one that cancels with that negative so that we have a positive power here. Okay, so what I'm going to do will be this. Okay, what I'm going to do here will be this. So I'm going to say okay, I'm going to say let's divide both sides by x to the power minus minus 3 over 2, and then we see what we're going to get. Okay, so we have the expression x to the power half is equals to 4x to the power minus 3 over 2. So what I'm going to do here is just divide both sides. Okay, I'll divide this side by x to the power minus 3 over 2. Okay, okay, so this will be okay, and then even here I'm going to divide by the same thing. So now here we are going to use indices. Okay, so here x and x are the same things. So we're going to say x half and then minus, okay, since this one is in the denominator, so we are subtracting, right? So minus 3 over 2 is equals to, and then here I'll isolate the 4 there. Okay, so if I isolate the 4, it will leave x to the power minus 3 over 2, x to the power minus 3 over 2. So this is the same thing. So it just gives us what? A 1, right? So this will be 1 here. So now I can deal with this one. So it will be x, and then here it will be half plus 3 over 2 is equals to 4. Okay, so let's add this. We see what we're going to get. So 1 over 2 plus 3 over 2, this will be 2, and then here I have 1 plus 3, so this will be 4 over 2. 4 over 2 is just 2. So it means this power here just becomes 2. Okay, so what I have now there is x to the power 2 is equals to 4. Okay, so we've simplified that one. And from here, we see that we can find the values of what? Of x. Okay, so we're going to say x is equals to the square root of what? 4. Okay, so we'll get plus and minus. So x will be equals to plus or minus 4. But in the question, they've said x should always be greater than 0. So we're not going to consider the x is equals to minus 4. We're going to discard it. Okay, so the only valid answer that we're going to have is x is equals to what? 2. So this one here is the x coordinate of the stationary point. Okay, so to find the stationary points now, we have to substitute this value of x into the original equation. So it will be y is equals to, okay, 4, and then I put 2, the root of 2 plus 48 divided by the root of 2 minus the root of 8. So what are we going to get here as our value of y? Okay, what are we going to get as our value of y? So what we can do here is, okay, we can try to rationalize the guy which is on the middle here, because this one has root of 2 in the denominator. So this one here it's just 8 root of 2. Then I can try to rationalize this. Okay, so it would be 48 over root of 2. So if I rationalize it, I multiply by root of 2. Even there, I multiply by the root of 2. So this would be 48 root of 2 divided by, okay, root of 2 multiplied by the root of 2 to just be 2. So this is 48 root of 2 divided by 2. That will give me plus 24 root of 2 and then minus, okay. I can express this 8 as a certain number multiplied by root of 2. So I know that 8, okay, the root of 8 is the same as the root of 2 multiplied by 4. So this will be the same as the root of 4 multiplied by the root of 2. So this will just give me 2 root of 2. So I can express 8 as that. So I'm going to write here minus 2 root of 2. So I'm making it root of 2 here so that I have a common thing so that I can add them what? Easily. Okay, so now here we're just going to add. So this is 8 root of 2, 24 root of 2 and minus 2 root of 2. Okay, so we can start with this one here and this one. So what do we get when we subtract? We get 6 root of 2, and then this 6 root of 2, we're going to add it with the 24 root of 2. So we're going to get 30 root of 2. Okay, so this is the y coordinate of the stationary point, or in other words, the turning point. Okay, so we can say, therefore, we can write the turning point here. Okay, we can say the turning point or the stationary point is simply 2, 30 root of what? 2. Okay, so that's the those are the coordinates of the stationary points. We found them. And then next, we determine whether the stationary point of C is the maximum or minimum, and then you also give a reason. Okay, so how do you determine if it's a maximum or minimum? Okay, so you use the second derivatives. So that was the reason why they told us to find this second derivative here. Okay, so you get the x coordinate of the stationary point, and then you substitute it into the equation for the second derivative. Okay, if a value that you're going to get, okay, if a value that you're going to get will be greater than 0, okay, we are going to say that that point is a minimum. If a value that you're going to get is less than 0, we're going to say it's a what? It's a maximum. Okay, so let's try and see what will happen when we get the x coordinate of this stationary point here and substitute it into the second derivative. Okay, so we're going to say d2 dy dx d2 at x is equals to 2 is equals to 3. Where there's x here, I put 2. So it would be 2 to the power minus half, okay, and plus 36. And then I put 2 to the power minus 5 over what? 2. So how can I simplify that now? Okay, how can I simplify that? So we know that if the power is negative, okay, it can go down there. So this is the same as 3 divided by 2 to the power half. But 2 to the power half, okay, we know that it is the square root of 2. Okay, and then need to be plus 36. This one has a negative power, so it can go down. So it's just this part here. It's the same as 1 over 2 to the power 5 over 2. And then this 5 over 2, okay, is the same as this. It's the same as the root of 2 multiplied by 5 like that. Okay, so what I have in the denominator here will just be the root of 2 to the power 5. Okay, and then we can simplify this expression now to find our second derivative value. Okay, that will help us determine the value that we have. But these numbers here are all positive. Okay, so without even finding the final answer, you can see that this number is a positive. Even this number is also a positive. Okay, so when you add a positive number to a positive number, you're going to get a positive number. Okay, so just from here, we can conclude that this one here is greater than what? 0. So if your second derivative is greater than 0, you're going to say this point here is a minimum point. Okay, so that's the reason there. Because the second derivative is greater than 0, we are going to say this point here is a what? A minimum point. Okay, so we are done with question 1A. We'll go to question 1B. Okay, so question 1B, they're saying find the integral of 3x squared plus 4x minus 5 dx. Simplify each term. So when we are integrating now, we're doing the opposite of what we are doing when we are differentiating. Okay, so remember we had a x to the power n, right? So I said when you are differentiating this, you're just saying n a x to the power n minus 1. Okay, so now when you are integrating, okay, when we are integrating this term, what will be doing is that we're going to say a x, and then to this n, we're going to add a 1 like this, and then divide by the new power, which is n plus 1. Okay, so here we're integrating, there we're differentiating. So we're just doing the opposite. Okay, all right, so let's integrate. So we have the first one, the saying the integral of 3x squared plus 4x minus 15, and then dx. Okay, so when we integrate this, it means this one here, it will be 3x. We add the 1 to the power. So from 2, it becomes 3. And then we divide by the new power, which is 3. Plus 4x. This x has a power 1. So we add another 1, so it becomes 2. And then we divide by the new power, 2. Okay, minus 15x. Okay, because this 15 here, it means it is 15x to the power 0. So we add a 1 to this. It becomes x to the power 1. Okay, and then we divide by the same power, which is what? 1. Okay, so what are we going to get there? Okay, we're going to get this same thing plus a constant of integration. Okay, remember we said when you differentiate a constant, it becomes 0. So when you are differentiating, the constant disappears. Okay, so when you are integrating now, you just have to add a constant c to show that there was a constant somewhere. We don't know the constant, but just represent it by what? By c. Okay, so this one here is the integral of this guy. So you can try to simplify it further. Okay, but by just dividing. So here 3 and 3 go. We have x to the power 3 plus this one here to be 2x squared minus 15x and then plus c. So this is the integral of what we had there. All right, so this one is very simple. Let's look at 2, B2. Okay, so B2, they're saying given that B is a constant, okay, and that the integral from B to 4 is given of this expression, I mean, is equals to 36, show that B to the power 3 plus B plus 2B squared minus 15B is equals to 0. Okay, so here, what we're integrating here, okay, had no limits. Okay, no wonder we're adding that constant c. Okay, so these are called indefinite integrals because they don't have limits there. Okay, but this one now has limits there, so we're going to call it as definite integral. So there'll be no need for us to include that constant of integration once we do that. Okay, so we're going to say b to 4 of 3x squared plus 4x minus 15. We notice that this is the same expression that we had on the first question. Okay, so what was the integral that we got? We got x to the power 3, okay, plus 2x squared, and then minus 15x, and then plus constant. But here, since this one has limits, so you don't put the constant. What you put, instead you put the limits here, okay, that you need to substitute. So this one here is from b all the way up to 4. So you have to substitute this 4 into this expression, and then you say minus, you substitute this b into this expression. So what we are going to have is, where there's x, we replace 4. So it will be 4 to the power 3 plus 2, 4 to the power 2 minus 15, 4. Okay, and then you say minus. So this was the first part when we substitute 4 into this expression. Now we will be substituting b. Okay, we'll be substituting b. So if we substitute b there, it will just be b to the power 3, okay, plus 2b squared minus 15b. So this is what I have. Okay, so remember we were told that this whole integral here equals what? 36. So I can equate this to 36. Okay, and try to simplify. Okay, so let's try to simplify. So here I have 4 to the power 3. 4 to the power 3 is what? It's 4 multiplied by 4, so that is okay, so it is 4 multiplied by 4, which is 16. Then 16 multiplied by 4. which will be 64. So here I'm going to have 64 plus, then here it is 4 squared, okay, which is 16, and then 2 multiplied by 16 is 32 minus it. Here 15 multiplied by 4, which is minus 60. Okay, so here what I'm going to have is I can say 64 minus 60, it will give me 4, and then that 4 plus this, okay, I'm going to get 36. So it means this whole expression here becomes 36. Okay, so I can write it on top here. So that expression here to be 36 is equals to, this one here has become 36 as well. And then I have minus b to the power 3 plus 2b squared minus 15b is equals to, oh, no, it's not equals to anything. Okay, that's just the end there. Right, so what we see here is that 36 can follow the other 36. So it will be 36 minus 36 is equals to minus the root of 5, the root of b to the power 3 plus 2b squared minus 5b. Here you're going to get 0, and then here you're going to get minus, okay, b to the power 3, let's write that properly, plus 2b squared minus 15b. Okay, so here we can divide both sides by -1 to eliminate this, even here -1. So what we end up with is what we are required to show. So end up with b to the power 3 plus 2b squared minus 15b is just equals to 0. Okay, so we can say hence shown. All right, so once we show this now, the next question is hence find the possible values of b. So here we see that b is common there. So we can factorize the b plus remain with 2b minus 15 is equals to 0. Okay, so this means that the b is equals to 0 and whatever we have inside here is also equals to what? To 0. So this is just a quadratic in terms of b. Okay, so the product will be 1 multiplied by minus 15. Sum will be 2. Okay, what will be the factors? So the factors there, we're going to use minus 3 and positive 5. So this will be b squared, okay, minus 3b plus 5b. So this part here is the same as 2b. So we're just writing 2b in a different way. Okay, and then I have minus 15 is equals to 0. So I group this one, and then I also group this one. So I have b minus 3, and then plus, here I'll factorize 5b, not 5b, sorry, because the b is not common there. So I'll factorize the 5, then I'm going to remain with b minus 3 is equals to 0. So from here I'll have b minus 3, and then b plus 5 is equals to 0. Okay, so when I equate all these to 0, I'm going to get, my first answer is this one, remember? It is b is equals to 0. When I equate this to 0, I'll get b is equals to 3. When I equate this to 0, I'll get b is equals to what? 5. Okay, so this one here gives us the values of what? B. Okay, so we are done with question 1. Okay, so thank you so much for watching this video. If you'd like to access full solutions to that paper, you can subscribe and access them at discretelearning.com. Again, if you're having challenges with your pre-med or your NS, okay, in any of these courses that I've listed here, biology, physics, chemistry, or math, okay, I would like to tell you about a platform that can be a solution to you. So that platform is discretelearning.com. Okay, so we have both the website and the mobile app, and these platforms have videos that can actually help you to better understand whatever you learn in class, and just show you a simple way in which to answer questions. Okay, so you can subscribe and get help in any of these courses: biology, physics, chemistry, or mathematics. Okay, both semester 1 and semester 2. So for whatever course you register for here, you're going to access tutorial sheets, full videos for tutorial sheets. You're going to access full videos for assignments. You're going to access full videos for past quizzes, for past tests. Okay, you're going to access full video solutions to past mid-semester exam papers and also final exam papers. Plus, okay, you have an opportunity to consult from us. So maybe if you are watching one of our videos and you do not understand, you can simply inbox us to consult on that particular question. Then we'll be able to help you. Okay. And a bonus is that we also have live classes. Okay. So these live classes, we explain concepts to you on a live class. So meaning you're able to we're able to interact with you and you're able to ask questions there and then so that you understand the concept. Okay, and our videos are basically tailored to your university syllabus. Okay, so we are teaching what you need to know in order for you to actually pass and get to understand these things very easy. So I'm just going to show you that we have solutions to, for example, I'll say all the math tutorial sheets. Okay, it's the same in chemistry, the same in physics, the same in biology. So when you come here, math tutorial sheets, tutorial sheet 1 is on algebra. So all these questions here were solved in a very simplified way that you can understand. Okay, so all these questions here in tutorial sheet 1 were solved and the videos, they are available on the website. You can watch at your own time, at your own pace, even in your blankets. Okay, tutorial sheet 2 is on exponentials and logarithms. Again, we solved all these questions that you can see in this tutorial sheet 2. And the videos are waiting for you on the website. Okay, so once you watch these videos, you understand the concepts clearly and you'll be able to answer questions in your assessments, like the quizzes, the tests, the mid-semester exam, even the final exam. Okay, there's also tutorial sheet 3 on functions. Again, we solved all these questions here. Okay, how to limit the domain, how to sketch the functions. We talk about the quadratic functions, um, and such things. Okay, all those questions have actually been solved. How to find the composite here, all these things we've solved. The videos are there available for you at any particular time. Okay, so that was tutorial sheet 3. Tutorial sheet 4 is on sequences and series. Again, we've solved all the questions in this tutorial sheet. Okay, all the questions here have been solved. They're there. You can access them on the website. Tutorial sheet 5, differentiation and integration. This is a topic that most students find difficulties with or challenges. Okay, we've solved. Okay, I've shown how you can differentiate in a very easy way. Okay, so how many questions did this tutorial sheet have on differentiation? It had how many questions? 5 questions. We've solved all of them and you can access them on the website. Tutorial sheet 6 is on descriptive statistics. Again, we've done justice to this tutorial sheet. We've explained all the concepts clearly and you can access them on the what? On the website. Okay, so all these questions have been solved. Tutorial sheet 7, which will be the last tutorial sheet on probability for semester 1, okay, has also been solved. So all these questions that you can see here have actually been solved and they're available on the website. Okay, so in addition to the tutorial sheet, guys, you get to access the past papers, the quizzes, the tests, the mid-semester exams, the final exam papers. You get to access them, okay? And also the topic lessons so that you understand the topics fully. They are all available on our website. So we also have this assignment 1 here. It was solved. Okay, so assignment 1 had like 2 questions. There's this one on pharmacokinetics. We solved it. And then question 2 is on exponential decay and growth, okay, of bacteria. We've solved all these questions here and they are available on the what? On the website. So if you need help in any of those courses that are actually listed here, biology, math, physics, chemistry, you can subscribe at discretelearning.com and you're going to access them. So you can contact me on these 2 numbers here, okay, if you want. Again, let me just show you the website for those who have never seen it. So you just go to Chrome here and then type in discretelearning.com. So you can see the discretelearning.com there and then go search, take you to our website. So here, if you don't have an account, you need to create an account. So you just go to start learning now. Okay, then it will take you to the login page. So if you don't have an account, go here, create an account and then log in. But if you already have an account, just put your email, your password there and then log in. Okay, after you log in, these are the things that you're going to see. So you can see mathematics, chemistry, physics, biology, everything that you need uh, to help you. So for example, I'll just use the math folder or the math course. If you open it, you go to your particular university. Okay, so if you're from Unilas semester, first semester, you go here. Unilas second semester, you go there. But if you're from any other university, you go in general mathematics. If you're from Apex, you use those. So I'll just use the semester ones here. So if I click on the semester one, you see that it's going to open and I'm going to have four folders: topic lessons, summarized, tutorial sheets, past quiz test, and exam paper. So if you go, for example, in the tutorial sheets there, okay, you're going to find videos for all the tutorial sheets. So you go to your intake. Okay, so the current intake now is 2026 January. I'll go in the 2026 January there. Okay, and you're going to see here the assignments are there and all the tutorial sheets are there, so you can learn and I mean, you can watch and learn from these videos at your own particular time. And if you have any question, you inbox us. Okay, so my number for those who want to register is 0779 96 40 10. So that is Tutor Pro Solutions. Okay, but if you just want to self-register, you can check the registration video guide in the description below here. It's going to show you how you can create an account on the website, how you can register, how you can pay and access these, okay, automatically without even needing any of my team members. All right, so thank you so much for watching. This has been Tutor Pro Solutions. Until next time, always there for you, and I wish you all the best in your exams.